Hello everyone, this is Vardis from the PODAAC, and I'm going to be giving you an overview of how to discover Aquarius data that we host at the PODAAC. As mentioned last week, PODAAC is the official repository for the Aquarius SAC-D mission, so we maintain all the data sets produced by the mission here, and we archive it, make it available to the science community in general. Okay, so let's get going. So as I also mentioned last week, the gateway to all PODAAC data and informational resources are all available through the PODAAC Web Portal. Okay, and how do you get to the Web Portal? Simply in Google, just type in PODAAC, PODAAC, and what will come up is our main web page. And through that, you can access data, a range of tools and services for working with data, and also some visualization capabilities that we'll be talking about next week. Okay, so this screenshot basically illustrates how the homepage looks like. And there's several ways that you can actually sort of start searching for and discovering Aquarius data. On the main toolbar, there's a menu option that says Dataset Discovery. You can click on that and then go search for data sets that we host by parameter, by mission, by instrument, etc. Okay, but probably the easiest way to immediately start searching for data is simply to use this search toolbar that you can see on the screenshot to the right. And essentially, you can just type in a keyword, and it will search our entire data catalog, okay, for all data sets that match that expression that you've typed in. So in this example, just type in Aquarius, and what you'll get back is a listing of all Aquarius-related data holdings that we have at the PODAAC. Now, I just wanted to point out that if you click the little question mark button, you'll get instructions as to how to create more complicated, sort of compound keyword search terms. Okay, so for example, you can type in Aquarius plus project, and that will limit the query to just data sets that are related specifically with the Aquarius mission. So no sort of PI-provided data sets, which if you type in just Aquarius, you'll get a complete listing of everything that has a keyword of Aquarius. So the mission data plus 7 of the CAP, JPL CAP Aquarius data sets. Okay. Next slide shows you exactly what happens when you execute that Aquarius search. And in fact, on this screenshot here, you can see that you can already start adding some additional filters to limit the list of catalog entries that are returned. But by default, when you type in Aquarius, you'll get currently, for the version 4 Aquarius datasets that are available at the PODAAC, a total of 105 products listed in this that are available via our cataloging system. Okay, and so that's a lot to deal with, perhaps. And so there are capabilities provided that allow you to sequentially filter down and get to the precise data set that you may be interested in working with. And we call this feature faceted search. Okay. And the faceted filtering capabilities are located on the left panel of the web page that comes up when you execute a search. And so you can filter by, for example, the processing level of the data set. So either a level 2 swath data set or a level 3 gridded data set. Or you can use additional filters such as the resolution, if it's a swath data set, or the grid spatial resolution, or temporal resolution. You can select, this indicates basically the range of products that we have in terms of time interval, okay, for Aquarius. And that little number to the right tells you actually how many data sets, daily data sets related to Aquarius, okay, we actually have available. So out of the 98, out of the total 105 Aquarius datasets listed, 10 of those are daily data products. Okay, and so you get this listing. You've now filtered it down to those items that you're particularly interested in, say a 7-day weekly snapshot, okay, level 3 data set. And then you want to find out more about one of these data sets. So essentially from that listing, you just click on the hyperlink on the main sort of the long name of the data set that's listed here in blue. And essentially then what you get is a series of data set information pages, okay, that provide quite a lot of very useful descriptive and other information about the data set that you're looking at. So there's several tabs. The first one that we're looking at is the sort of the data set information tab, and you can see there the long name is given, the URL. If you want to pass on, if you want to convey to a colleague, oh, I'm working on this particular data set, you just copy this URL there and then email it to him, and then he'll be able to check out this data set catalog entry as well himself. You have a lot of, this is just a sort of a truncated snapshot of what you'll see on the screen, but there's a lot of useful information in here, such as the latency of the data of the data set, the short name, the temporal resolution, spatial resolution, the frequency with which the data is available. And then relatively new, we now have DOIs for all of our Aquarius data sets. So for those of you who are familiar with DOIs, these are digital object identifiers. They're used originally, I think, for publications, but now you could actually uniquely reference a data set with this uniquely registered dataset DOI. Okay, so if you want to use a particular data set in an analysis that you then publish, basically you can cite that by just quoting the DOI and maybe even additionally adding the link to our catalog entry. The next tab, which is perhaps one of the more important ones, is how do you actually get to the data files, okay, so that you can start working with the data. And all of that is under the Data Access tab. And you can see some links are provided and some additional information. So essentially the URL to get to that specific data entry location on our public FTP site, or if you're using the PODAAC web service, okay, those links are provided. And some of the other data sets, the level 3 products that we have, will have additional items listed underneath here. And you can see also there's information about the file format, and Aquarius data are all compressed, okay, VZ2 compressed. And then in addition to how you access the data, there's also information on applicable tools that are relevant for this particular data set that you're looking at, and also reader software in MATLAB and IDL that we provide for these Aquarius data sets. The next tab over is documentation, and as I mentioned last week as well, first and foremost amongst those the user guide that has been developed for Aquarius, which is really a one-stop shop, treasure trove of information on Aquarius data, how to access the data. So if there's one document that you read, I advise that you take a look at this. And then there's pointers to other project materials on our FTP site, etc. The other tab that's highlighted here is what is referred to a granule or a file listing. And we'll define some of these terms like granule in a minute. But essentially, it's kind of like an FTP directory listing. You can just click on any of these elements within the browser without leaving the dataset information page that you're looking at, and sort of browse through the hierarchy of data directories and look at data files and resources that are available. So these little numbers in parentheses indicate the number of data files in that 2011 data folder for this level 2 Salinity product. The final tab, and we don't have a slide on it, is the citation tab, but it gives this sort of the official sort of way in which if you wanted to use or quote this data set in some kind of publication, the way that you would reference that. Okay. So there are a few terms that I think it's important that everyone clearly understand when working with data, Earth science satellite data in general. And so I just wanted to introduce some of these concepts in case people are not familiar with them. And the first of those is the concept of a data set or product level. Okay, and the level really reflects the stage in the data processing sequence that has produced that data product. So in terms of satellite data sets, they range from level 0 all the way to level 4. And in the series of bullet points, I kind of define not necessarily official NASA sort of definitions of what these are, but sort of a more perhaps accessible definition of what these different product levels mean. So level 0 is essentially the raw instrument and telemetry data coming down from the satellite. Level 1 data contains the raw data that's now being processed, okay, to some degree into orbital or swath data files, okay? And these, in the case of the Aquarius level 1A, contain the instrument count and satellite navigational telemetry data. I just wanted to point out as well that in this column on the right here, I indicate what the file naming convention for that particular data product for Aquarius actually looks like. And there's certain nomenclature and the convention that's applied for all of these Aquarius data products. And what essentially will differ for a different data file is the date information here, okay, for each product type. Level 2 now takes the level 1 data and does some additional processing to it, okay? And again, it's orbital data, so in the case of Aquarius, 15 files per day, each of which contains the actual georeferenced geophysical measurement data, okay? So by geophysical measurement data, we actually now mean the retrieved salinity, wind speed, and other variables, okay, from Aquarius. There's another stage of processing that then takes the level 2 data files and then pools and grids them, aggregates these data and then grids them, okay, into what are referred to as the Aquarius standard data products, level 3 data products, which are all on 1 degree latitude, longitude, spatial resolution for various time intervals. And this little table here below illustrates that, at level 3, we have a range of data products for the different parameters that Aquarius processing returns: salinity, density, wind speed, and ancillary SST. So by ancillary, this is not actual data that Aquarius itself measures, but it's used in the Aquarius processing, and it's important in terms of interpreting some of the salinity fields that we see in these other data sets. So that's why that is included as well. Okay, and in terms of time intervals, we have now, given that we're at the end of the mission, we have a range of time periods for which gridding has occurred, okay, and we have products for each of those, ranging from daily, 7-day, monthly, annual, and even some quote-unquote climatologies for the duration of the mission. And then there is another thing that you should be aware of. We have basically the combined, so level 3 products based on the combined level 2 data, or and also versions of that just look at the ascending and descending paths of the satellite. And this again, these, I think the typical user would just be interested in the combined product. Ascending and descending is used mainly for the CalVal process in troubleshooting any issues. Level 4, so the Aquarius mission does not actually produce any level 4 data sets, but I'm going to define them here. These are considered to be value-added gridded data files. And essentially what level 4 does, it's value-added because it integrates data potentially from multiple sensors or applies some kind of more advanced statistical or interpolation procedure in producing the data set. Okay, another very important term that some of you may be familiar with is metadata, and that will be used, that term is cited quite a bit in this presentation. Basically, metadata is contextual information that describes and facilitates the correct interpretation of data values and their quantities. And some examples include, the units. So what a data value, you get a data value in the data in a given data set. How do you interpret that? You need to know, to do that, you need to know what the units of that value are. And that is an example of a metadata element, okay? And there are various others. So, and metadata is essentially comprised of is a property that is comprised of an attribute and some kind of associated value. So in our units example, the attribute would be units, and the value that it takes is PSU. It's important to understand that metadata exists also at a variety of levels. You have metadata at the dataset level. So all these various fields that I described when covering the dataset information page, such as the short name, DOI, resolution, etc., all of these are examples of dataset level metadata, okay? And the values are actually the entries, the descriptions, etc., that are in that catalog reference. Another thing that everyone should understand is that PODAAC develops and catalogs and archives all of this dataset level metadata. But in fact, we also essentially convey automatically all of our metadata information, okay, at both the dataset and the granule level, which I'll be defining in a minute, to a centralized NASA metadata repository that's now referred to as a CMR, the Common Metadata Repository. Some of you may be familiar with what was referred to as GCMD and ECHO repositories. Well, that has been sort of rebranded and re-architected in the past. Okay, and now some additional terms to define. So we have dataset level metadata, and then we have metadata at the granule or the file level. And it's possible to include this type of granule level metadata because these days science data files such as HDF and NetCDF have the ability to embed that information in there. So these are referred to as self-describing data formats. And within a granule or data file, you have metadata that is global. So that's at the header sort of level as indicated here, okay? And then you have variable level metadata. And these are attributes that describe the properties of individual file variables contained in data arrays. And amongst those, you have structural and descriptive metadata. These are elements that describe the data arrays or attributes and properties of the variables themselves. So I just wanted to point out very briefly here that there are now metadata standards that have been developed in terms of what these attributes are and what values that they should take that have been developed by such as the CF convention and ACDD. And these are very important because they ensure the interoperability of data sets that are produced these days. I believe this is the final slide, and it essentially then shows that you can actually drill into a data variable and actually then look at the data values themselves. So at this level now, we're actually looking at data values. Okay, that concludes this part of the trip, and I'm going to